was stuck in 7 minutes. 1 minute. Time. What I got for today? Today my topic is angular and frequency modulation. If we have carrier signal like max cosine omega 0 time plus phi 0, and I would like to use it for transfer of my info signal, I can use angular shift, so phi will be some scale factor, phi 0 multiplied by my signal. It will be angular modulation or phase modulation, or I can try to use frequency modulation. In this case, I will have Umax cosine of 1 plus modulation depth, my signal, omega 0 time plus phi 0. I can use phase or frequency to encode or to carry my information. These two types of modulation are very are close in case of small deviations, small depth of modulation. there will be no visible difference. Anyway, let's start with angular modulation. Again, modulated signal or max cosine omega 0 time plus my signal to transfer. What it will be? S is 0. In case positive or negative change of S. Here will be my change. When not frequency but angular shift will be maximum. At the moment when my signal is maximum or minimum, this difference between the maximum difference is called deviation. Complete phase of modulated signal in omega 0 time plus instant phase, we can do one thing. We can introduce idea of instant frequency. In any moment of time, frequency can be found as a first derivative of instant phase. In our case, it will be omega 0 plus k multiplied by first derivative of my signal. Just to remind, instant phase can be found as integral from 0 to time of instant frequency plus phi0 at 0 time. In case, what in case? Nothing stops me from using frequency. This was written for angular modulation or phase, correct phase modulation. In case of frequency modulation, instant frequency will be omega 0 plus some k s. This k actually characterizes depth of modulation. Instant phase of modulation will be of modulated signal omega 0 need time here. Plus output time. And if it was present, phi 0. I can write equation for my frequency modulated signal as O max cosine omega 0 time plus integrate from 0 to time this time plus phi 0. Here we can also define idea of deviation, maximum and minimum shift of frequency from stable or zero signal mode. Now for simplicity, I will assume that my signal is a very simple for simplicity it's simple sine of omega s o. Case of angular modulation will be beta sine omega st. Here beta is an index of modulation. Index beta. Full phase of my signal will be omega 0 time plus beta sinus omega s time. O max cosine omega 0 time plus beta sinus omega s. Instant frequency of this will be, we can find it as dx time as first derivative of it, or it will be omega 0 plus beta omega signal cosine omega signal time. So here both phase and instant frequency are changing in accordance with harmonic law. Maximum deviation beta omega s. Frequency deviation. Angular deviation index can be written as, since omega deviation is beta omega s, so beta delta omega divided by omega s in my case. In general, we see the same for frequency modulation. They are very similar. In small indexes, you cannot tell which one is in front of you. But okay, in case of angular modulation, frequency deviation is proportional to omega s, and index is constant. So here bet will be constant and frequency deviation will be beta omega s. In case of frequency modulation, deviation of frequency is constant, but bet depth will be deviation divided omega s. Question now about spectrum. What we will see in frequency space. Angular modulation or max cosine omega 0 time plus beta omega s time. Angular modulation. We can rewrite it as O max cosine of beta sine omega s t minus 1 second cosine multiplied by cosine of omega 0 time. Now correct. Minus sine of beta sine of omega s time multiplied by sine of omega s time. Okay, I'll correct this way. Not a very nice formula. Simple case we can take a simple case, okay, just for demo I can take a very small modulation index. In such case cosine of beta sine omega st can be approximately assumed 1 unit, and sine of beta sine omega st. Approximately beta sine omega 0 prime. Yes. This allows to write approximate formula of maximum cosine max cosine omega 0 prime plus beta by half cosine of omega 0 plus omega s time minus cosine of omega 0 plus omega s minus closes 1, closes 2, closes 3. Yeah. Minus omega s. So, what we see? In case of low betas, small betas, we see something similar to amplitude modulated signal. Take a look. Central frequency plus omega minus omega, but with one difference, this minus sign. So small deviation, just invert one of the sidebands of amplitude modulated signals magnitude, it will be frequency, case magnitude of component, what you see, omega 0, omega 0 plus omega signal, omega 0 minus omega s. And this one should be inverted. Maybe I can show it in reality. What do I have here? My setup. Here, this generator supplies me signal for modulation. It's single tone signal. It is connected. Okay, it's simple harmonic signal. This generator takes its signal and performs at this moment an amplitude modulation of 32 megahertz harmonic signal. This 32 megahertz signal, I have problem with such high frequency signal because my scope isn't capable to operate correctly with such signals, such frequencies. So I use this receiver to transfer signal from 32 megahertz frequency to 4 megahertz. And from receiver's interim frequency, I took signal to my scope. Here is inputted modulated signal for my scope, and here, red line, is spectrum. Central line and two side lines. Frequency Z 2 kilohertz. Here. Central frequency, and where is the second one? Oh. Difference between them. Plus 2 kilohertz, and here the sideband bit crippled, minus 2 kilohertz. Amplitude modulated signal. For illustration, I'm adding third harmonic to my signal. Here. I have added 30% of third harmonic. Net bit of the fifth. Okay. Maybe I return to single tone signal. Now, frequency modulation. I have switched my generator into frequency modulation mode. You see, nothing changes amplitude because only frequency changes. I will expand signal later. Maybe, wait 1 second. Maybe I can use zooming function on this one. Ideal. Okay, I'll get it a bit later. I'll show the signal. Now, what I like to do, I will increase modulation depth. At this moment, frequency deviation is something like 5 kilohertz. I will increase frequency deviation. 15 kilohertz. Oh, sorry. Too fast. I'm increasing frequency deviation. Deeper, deeper. Oh, at the center. Here. Steady increasing deviation. You see, central line disappears and multiple side line appear. Spectrum, very small deviation, 1, 2. Higher deviation, this one lesser, 1, 2, 3. At true high deviation, I will see something like London Bridge. I will compress picture. 1 second. I need more powerful modulating signal source. See what happens? Keep it asymmetric. Overrange. Small deviation, higher deviation. It widens and widens. Frequency of modulated signal 2 kilohertz. And width of this beauty now with 75 kilohertz of deviation will be double, approximately 130 kilohertz. So it takes wide frequency area. Small deviation, large deviation. Where am I? Yeah. Mass model for this. Max sum, they starts from minus infinity to infinity. Bessel function. Bet multiplied by cosine omega 0 plus omega s time. Here's the mass model. For this. Oh, I promised. 1 second, I'll get it. I need a different scale. no deviation. I will set 0. Here is the 0 point. This is what's going on. No deviation, one signal. The higher deviation, the higher change in instant phase. No deviation, 75 kilohertz of deviation. 0, 75 kilohertz. Okay. How can I decode, how can I demodulate such signal? One trick. One that can be done, very simple. Frequency F0. Take a filter like this, set a work point on the slope of characteristic, time frequency, let's assume too large, this will not work. Let's say I use what? I use monotonal signal to perform frequency modulation. I will have such shift of frequency. Up, down. What will I get in time? When frequency goes up, signal goes down. And in opposite. I will get as a result an amplitude change. It will be amplitude relation. So very easy to decode. But such technique first, this part isn't, part of field characteristic isn't linear, so there will be distortions. And second, in case my transferred signal was subject to disturbances, additive type of disturbances, it will bear parasite or disturbance amplitude modulation. This modulation will go through such type of decoder. Better approach, relations detector. Input signal, it's a resonant contour. Resonance contour set to frequency omega 0 or interim frequency of your receiver. One F2, load resistance. Pair of capacitors, output voltage, all good except better add this compensation coil. So when frequency is equal to this resonant contact resonance frequency, system is absolutely symmetric and no output signal produced. In case frequency shifts, system is no longer balanced and voltage at load resistors there will be voltage difference which can be taken, this pair of capacitors. One moment to suppress parasite amplitude modulation, this coil is used. It compensates in case we have amplitude modulation parasites. One more moment, yeah, I forgot this point should be grounded. One more moment, to increase stability, I can also add load resistance here, but that's not main thing. To increase stability, I can do one thing to suppress pulse disturbances. Influence like from atmospheric discharge or kind of computation, they are fast. So if I add additional inertia to this system, here approximately 2-3 microfarads. These capacitors are approximately 300 picofarad. No, 10.5 megahertz. Normal operation frequency of the circuit. This for sound, this capacitor changed a bit because sound changed in relation to 10 megahertz. Sound changed very slowly, but pulse disturbances. For pulse disturbances, this capacitor, how to say, presents a huge inertia, so network will block pulse disturbances. Here is relation, so-called relation detector. Of course, you can also rely on Hilbert's transform, numerical, and also extract your signal. Maybe I can show real broadcasting. What? Of course you saw receivers with FM written on them. I can show real broadcasting. I just need to attach antenna to my receiver. Touch antenna. have true broadcasting signal. Let's start analyzing. 100 Hertz, 4 kilohertz, 5 kilohertz, 15 kilohertz. I think it's the end of hearing range of human. So this part appears to be sound. Yeah, it's a sound. But here we see something at 19 kilohertz and going forward here something happens. You see where my cursor stands? Stupid advertisement. Something happens there, you see? At the point of 38 kilohertz. Here you see example of stereo broadcasting. Problem: how to pack two sound channels, left and right, into one frequency modulated signal. Idea: 16 kilohertz. This part is simple sound. It's left plus right. And if you have left plus right, should be left minus right. Yes, 38 kilohertz. L minus F. Looks like amplitude modulated signal, but there is, where my cursor stands, should be carrier. Here should be line 38 kilohertz, but there is no such line. Because if it would be here, it would interfere with the TV, with the sound of TV channel. So, decision was taken to suppress it, to use balance modulation. But to demodulate different elements, I need a central frequency. Same way as with single sideband signal. Where to go? The NET engineers introduced so-called pilot tone. Here at 19 kilohertz, above hearing range of human, pilot tone is transferred. This pilot tone is used to synchronize local oscillator to recreate 38 kilohertz necessary to demodulate L minus R signal. Here's what's going on. Блах, блах, блах. Here. But that's not all. Where is the third harmonic of pilot tone? No, 50. Oh, here it is. You see something appears at the cursor. It's a data channel. RDS. Name of station, name of broadcasting zone, and a lot of another. RDS is very capable system. Data channel. So much objects in one frequency modulated signal. It's possible because frequency modulation yields much better quality. But frequency modulated signal occupies much wider space in a frequency shadow. When frequencies were distributed at, say, lower frequencies, there were no space. Space was at high, at meter depth, and space was granted with the kings, to say, with king size. So there is enough space for stereo broadcasting, for data channel, and in some station here at fourth harmonic of pilot tone. One more data channel, it's for business information. If you have subscription, you can get it. Mono sound, pilot tone, difference live track for stereo sound, and RDS data. So much. Okay. Switch my receiver off. Any questions? Questions? No. No question. If no question, I will end